Alright guys, today we are actually going to be starting the actual proofs of your projects. Okay, so I'm going to be going over what you're actually going to do for your project. Okay? We are going to have 4 warm-up problems today. I know you only see 2 right now, but they're kind of long and they will help you with your project. The math behind it will. So take a couple minutes, see if you can do these 2, and then we're going to go over it, okay? Please push pause, give them like 2 or 3 minutes to see what they can do, and then we're going to go over it. Thank you. All right. This statement on number 1, what is it actually representing? Okay, it's saying x plus y squared divided by 1 plus z squared. Okay, so each part of the fraction actually gets that square. And what does this actually mean? This is 2 FOIL problems technically on a fraction. So let's kind of FOIL these out and see what we get. The top would be x squared plus 2xy, 2xy plus y squared, okay, divided by, let's see, that would be 1 squared, which is 1, plus 2z plus z squared, okay, and nothing can actually reduce, so that's all she wrote. Number 2, these are 2 fractions, okay? To be able to subtract them, we need common denominators, right? So this fraction will actually need to be multiplied by x plus y, and then this fraction would need to be multiplied by x minus y, so they can actually have a common denominator. All right. So our denominator would be x minus y, x plus y, right? Okay. And on top is actually 2 FOIL problems, if you can kind of see it. There's actually 2 FOIL problems that we're going to have to go through. So the first FOIL problem is right here, okay? A plus b times x plus y. Alright, and you end up getting ax plus ay plus bx plus by. Okay? Minus, oh man, I'm going to run out of room, man. Okay, minus, because of this minus sign, you have to be very, very careful, okay? Because what is that going to actually do to all of your actual things after this, okay? It's going to change the signs, right? Because that negative is going to distribute to everything. So what are you going to end up with? A negative ax, a positive now, ay, okay, a positive, let's see, how can I kind of write it down here, okay, a positive bx and a negative by. Sorry about that. Okay, now let's kind of look at what we have. Alright, I have a positive ax here and a negative ax there, so these are going to cancel. Okay. I have a positive ay and a positive ay, so if I add them together, I get 2ay, right? Okay. I have a positive bx and a positive bx, so I have a plus 2bx. And then a positive by and a negative by, so those will cancel out, leaving me with can anything actually reduce? No, because they are binomials and they have to be exactly the same to be able to reduce. So there's my answer. All right, your next two formula problems is right here. So please, again, push pause, give them like 2 to 3 minutes to try to figure these out, and we will go over them. Thank you. All right. This one is set up a little bit different than that number one, right? I actually have a fraction plus a fraction squared. Okay, so this is a FOIL problem, but you're actually going to be multiplying fractions. Now just remember, when you're multiplying fractions, you're multiplying top by top, bottom by bottom, right? Okay? So let's kind of think about this. The first term times the first term would be x squared, top by top, over y squared. Okay? The next term would be the first term times the second term. If you look at that, those two are reciprocals of each other. Okay? So what's going to happen to the x's and y's? They're going to cancel. What happens when both things cancel? What are you left with? A 1. Okay? Next one we're going to do is the second term times the first term, right? So we're going to have a plus 1 again, because they're reciprocals. And then finally, the last term times the last term is just going to be y squared over x squared. Okay? So, combine like terms, we have x squared over y squared plus 2 plus y squared over x squared. Alright? And I just needed to show you guys how those reciprocals multiply together and that they equal 1. Okay? That's what we were kind of looking at on that one. Alright, number 4. They want us to factor this. Well, we have 4 terms. And if you remember how to factor with 4 terms, that's that whole grouping thing. Alright? Where you would have to group the first 2 and the last 2 together. Alright? And then factor them out and see what is left over inside of the parentheses are both the same. Well, right away I notice a problem. If you look at the second set of parentheses, x to the third plus y to the third, can anything factor out of that? No. So what I'm going to get out of both of these is not the same. So I might have to rearrange these in order to actually get it. So what I'm going to do is rearrange these because it's just addition. Okay? So I'm going to say, what if I had x, let me use a different color so it doesn't get all mixed up. Okay? So x to the third plus, let's see, x squared y. Because I'll be able to just factor out an x squared there, right? Plus y to the third plus y squared x, because I'll be able to factor out a y squared. Okay, do you see how I'm trying to help myself? I'm trying to reorder them so I can actually factor something out. Okay, there's my grouping. I'm able to factor out an x squared here. That would leave me with, what, x plus y. Okay, and remember, your goal is to see if you can get this exact same thing in the other one. Okay, so if I factor out a y squared, what am I left with? Y plus x. Alright, well, do I have the exact same thing? Yes, because with addition, you can just kind of switch those things around and they are the same thing. So what does this actually mean to us? What does our factors look like? X squared plus y squared, right? Because that's a plus, times x plus y. You will need to know how to do this. Okay. Just one quick reminder before we move on to our proofs. If I have x plus 3 over 5, okay, that's the same thing as saying x over 5 plus 3 over 5. Okay, I can actually split my numerator into its different denominator parts, just like that. Okay, but if I have 5 over x plus 3, okay, I cannot split this because there's nothing to split on top, okay? You cannot actually split a numerator by two different parts of a denominator, all right? So this can't be split. All right, so we kind of got to keep that in mind. Okay? All right, let's do this. Proving identities. When we are proving identities, we are going to be using the same skills as simplifying trig expressions. So the exact same thing as we did last week. The only difference is that I'm going to give you the answer to the problems, okay? You have to prove that it actually equals the other side. And yes, I'm not going to give you one that does not equal the other side. They will all equal each other. You have to prove that they do, though, okay? You have to actually show the work in steps that they actually equal the other side. Now, this is very, very important. You must pick one side of the proof to manipulate until you get the other side. You can only mess with one side. Okay? If you pick a side, that is the side that you have to actually work with. You cannot work with both sides at the same time. Okay? Here's our first proof that we're going to kind of look at. They look like this. Notice I have something on both sides. Okay. This is going to be tricky because some people are going to choose one side, some people are going to choose the other side, okay, and they're going to have to try to work through it. My thought process is whenever I'm trying to work one of these, is I try to pick the side that has the most things there to work with. Okay? So if you look at this one, the left side actually has more stuff that I can mess with, more stuff that I can actually do things with. Okay? So that's what I'm actually looking for whenever I'm working one of these. Then we have to use our tips that we learned last week to try to make this side right here equal to this side. So we are trying to turn this side right here into that side. That is our goal. Alright? So we're not just simplifying to one term anymore. We're actually trying to create the other side by using proper algebra and identities. Okay? You have to use the actual math behind this. You can't make up math. Okay? You can't just randomly come up with different things. Alright, let's get started. looking at the left side, I notice I have two things in the numerator and only one thing in the denominator because sine times cosine is technically one term. Remember, terms are separated by a plus and a minus sign. So I can technically split those two into two different fractions. I can say that this is the same thing as cotangent of theta over sine of theta cosine of theta minus tangent of theta over sine of theta cosine of theta. Now, this is very, very important. You have to bring down your equal sign. If you do not bring down your equal sign, I will take off points every single time that you forget it. You have to bring down your equal sign. Alright? Well, what can we do next? What are our options? Well, I have sine and cosine on the bottom of these two. So I kind of want the numerators to be in the same terms, okay, as the denominator. So I'm going to change everything to sine and cosine. It's my next step. Notice I'm showing every step. These are proofs. You have to show me every single step. Do not skip steps. Okay, so that gives me cosine of theta over sine of theta divided by sine of theta cosine of theta. Now I'm going to go ahead and put over 1, a little foreshadowing for you, minus sine of theta over cosine of theta divided by sine of theta cosine of theta divided by 1. Okay? So how do you divide fractions? You flip the second and multiply, right? Alright, so whenever you flip it and multiply, what happens? Your cosines on the first one cancel out, and then your sines multiply together, right? So you get 1 over sine squared theta minus, okay, well, let's look at the other one. If I flip that over, okay, the sines will cancel out this time, and the cosines will multiply together. So that would give me 1 over cosine squared theta. Bring down your equal sign. Okay, well, what is 1 over sine squared theta? That is cosecant squared theta. And what is 1 over cosine squared theta? Secant squared theta. Then you just kind of look up, because you always have to keep your goal in mind. You're trying to make it equal the other side. Is this the same as what the other side is at the beginning? Yes. So you have to bring it down. Okay? So you just put it right next to it. This is the format that I wanted in. So cosecant squared theta minus secant squared theta, just like that. Okay? And you put a little check mark saying that these are equal to each other. Okay? And you are done. In other words, you are showing that the left equals the right. Notice how my work goes straight down. Okay? I'm not going to the right. I'm not going to the left. My work is vertical. It goes straight down. Every step is straight down. That's what I want to see. Okay, we're going to start moving through these. Number 2, what should we actually look for? More things to actually work with. So which side should we be working with? I'm going to pick the left side. Okay? First thing that I see, I kind of want everything in sine and cosine. So this would be sine of x over 1 over sine of x. Plus cosine of x over 1 over cosine of x. Okay, bring down your equal sign. whenever I flip and multiply, the signs multiply together, so that gives me sine squared x plus, same thing happens to cosine, so cosine squared x. Right? Well, I know that this is an identity, which equals 1. Okay? Well, man, I ran out of stuff to do, didn't I? Well, let's kind of look back over, look at the right side. Sine x times cosecant x. Well, those two are actually reciprocals, right? That's an identity. So I can technically replace 1 with that statement. So I can say that this is sine x cosine x. I'm not cosine x. Sine x cosecant x, right? Because that's what 1 is. Equals, well, hey, that's my answer, right? So sine x cosecant x, and check. We're done. Number 3. Okay, again, on this one, the left side actually has more we can do with it because it's a fraction. I always try to pick these fractions, okay? So, let's see. Well, I see 1 plus cosine x on the bottom. So what could I actually do with that? Which one of our tips? I could multiply it by the conjugate? Yeah, let's try that. So the conjugate would be what? Multiplying it by 1 minus cosine x on both top and bottom, right? So 1 minus cosine x. Okay, so that's my operation that I'm going to be doing. So what does that actually give me if I do that? That's going to give me sine x minus cosine x sine x divided by, let's see, well, those are perfect squares, right? That's that difference of 2 squares kind of thing. So that ends up being 1 minus cosine squared x. Okay? Don't forget to bring down your equal sign. Alright. And why do you think I actually wrote the denominator like that instead of keeping it in its different parts? That's an identity. Very good. Okay, if you were thinking that. Great job. Okay? So what does that denominator actually equal? Sine squared x. So let's just go ahead and change that. So sine x minus cosine x sine x all over sine squared x. Okay, what else could we do? Well, let's see. We can actually factor out sine x on top, right? So we can factor that out if we want to. Okay, so that's an option. I also have 2 things in the numerator and 1 denominator. So I could technically split my fractions if I want to. So we have options, right? Okay. So let's see. Let's try splitting our fraction. Let's see what that takes us. So sine x over sine squared x minus cosine x sine x over sine squared x. Okay? Now whenever I reduce this, one of my signs go away, and I'm left with 1, right? One of these signs go away. Okay? Don't forget to bring down your equal sign. So this would give me 1 over sine x minus cosine x over sine x. Just like that. Alright. Well, 1 over sine x is the same thing as cosecant x. And then cosine over sine x is cotangent x. And if we actually look up at where we started at, was that what was our goal? Yes, that is actually what our goal was. So we're good. We're done. So this would be cosecant x minus cotangent x. We put our little check mark and move on. the next problem. Okay, on number 4, the first thing you want to do is pick a side. Obviously, you want to pick the left side because there's a lot going on over there. Okay, I have 2 fractions. They're already in sine and cosine, so I'm thinking let's go ahead and put those 2 fractions together. So we need common denominators, right? So this first fraction right here on the left, I'm going to need sine of theta, right? Because that's what this denominator is missing. Okay, and on this fraction, the other fraction, I'm going to need 1 minus cosine of theta, right? Because that's what this denominator is missing. Alright, so whenever I combine these 2, okay, at the bottom, it's going to be very simple. I'm going to have 1 minus cosine theta times sine theta, right? That's your common denominator. Okay, on the top, let's see, sine times sine is sine squared theta plus, well, those 2 are perfect squares, right? So I'm just going to go ahead and FOIL it out and see what we get. So we get 1 minus 2 cosine theta, let's see, plus, let's see, cosine squared theta, right? Okay, bring down your equal sign. Don't forget your equal signs, guys. Okay, let's see. Always kind of look, see what you got. First thing that I see is that I have sine squared theta and cosine squared theta. What does that actually equal? 1. So let's go ahead and replace that. So it's going to be 1 plus 1 minus 2 cosine of theta, all divided by, let's see, 1 minus cosine of theta times sine of theta. Alright, combine like terms and you get 2 minus 2 cosine of theta all over 1 minus cosine of theta sine of theta. Okay, I can factor out a 2, so that's 2, 1 minus cosine of theta, and I'm sure you guys can see why I'm doing that right now. Okay, divided by 1 minus cosine of theta sine of theta, right? Remember, whenever you're working these, you're always kind of keeping your goal in mind. You're wanting this to make the other side, right? So always keep that goal in mind. How can I get there? That's your objective. Okay, you're always trying to figure out how to get to that other side. So all through all these problems, you just be kind of thinking about that. Okay, these 2 cancel. You're left with 2 over sine of theta, right? Okay. Well, if you look up at the top, okay, what is my answer? What is my goal? 2 cosecant, right? So, hey, that's what that equals, right? So it's 2 cosecant. That's ugly S. There we go. 2 cosecant equals 2 cosecant. Trying to spell cosine here. Okay, cosecant, and voila, that's number 4. And if you notice, that was just like number 10 on your homework. So just kind of throwing that out there. Number 5. Okay, let's see. Tangent squared x minus sine squared x equals tangent squared x sine squared x. Well, if you kind of look at this, did we have a fraction to kind of pick from? No. I mean, they're both straight up. So does it matter which side I pick? Not really, okay? So let's see. I'm just going to choose the left side just because it comes first. Let's see. Let's go ahead and change everything to sine and cosine first. So this would be sine squared x over cosine squared x minus sine squared x. And technically that's over 1 since I have 2 fractions. Kind of want to keep that up. Remember, since I've chosen the left side, I cannot work on the right side. I cannot do anything over there. Okay? These are 2 fractions, so I can put them together. So this would give me sine squared x minus, okay, the common denominator would be cosine squared x. So that would be sine squared x cosine squared x, right? over cosine squared x equals. Okay? What could I do now? Let's see, I can factor out a sign. Okay, so let's try that. Sometimes it's just going to be like trial and error. What can you do, right? So taking out a sign, so that would give me 1 minus cosine squared x. Okay, and you can kind of see why I did that now. Over cosine squared x, right? Well, what is 1 minus cosine squared x? That is sine squared x, right? So this is sine squared x times sine squared x over cosine squared x. Remember, you're always looking for your goal in mind. What was our goal over there? Tangent squared x times sine squared x. Well, here's the sine squared x, right? And if you look at it, that right there is tangent squared x. So I pretty much hit my goal. All I have to do is write it down. So tan squared x times sine squared x equals tan squared x sine squared x. There's my little check, and I'm done there. Alright guys, here's number 6. Okay, now looking at this one, okay, let's see, we have fractions on both sides, so we can kind of choose from either side, okay? Remember, I always try to pick the fraction side because, I don't know, it seems easier to me, okay? Do you have to pick the side of the fraction? No, okay? Alright. Let's see, on the left side I have 1 over, let's see, cosecant and secant. On the right side I see sine, cosine. So you can't really do too much to the right side. So I'm going to go with the left side again. Okay? Let's see. I can change both of those to sine and cosine. Well, hey, my other side has sine and cosine, like in terms. So I kind of want to do that anyways. So let's see. 1 over sine x plus 1 over cosine x. Right? Well, those are two fractions on the bottom, so I can put them together using common denominators. So what does that give me? 1 over, let's see, cosine x plus sine x all over sine x cosine x, like that. Okay. What do you do whenever you're multiplying fractions? You flip the bottom and multiply, right? When you're multiplying fractions. When you're dividing fractions, you flip the bottom and multiply. So you get sine x cosine x over cosine x plus sine x. And hey, that's what we wanted, right? So sine x cosine x over cosine x plus sine x. And we have our little check mark and moving on. Number 7. Okay, let's see. This one's a little tricky if you don't know your Pythagorean identities yet. Alright? Well, first off, I don't have fractions, so it doesn't matter which side we pick. But I do see on the left side that I have 2 identities. Okay? Alright, so what does that mean for us? Let's see. Cotangent squared x is actually the same thing as cosecant squared x minus 1, right? Which happens to be the first term on the right side, so I'm kind of going towards my goal here, okay? Plus, well, what is secant squared x? That's the same thing as tan squared x plus 1. And hey, look, that's on the right side too, so I'm kind of going in the right direction here. The 1s are going to end up canceling because I have a negative 1 and a positive 1, so that gives me cosecant squared x plus tangent squared x, and hey, I got right to my goal. That one was very fast, very easy. And sometimes they're going to work out this way, and sometimes you're going to pick pick the wrong side, and it's going to take you forever to get over there. Okay? Just depends on how you work it. All right, number 8. Last one for today, okay? Let's see. Well, hey, my fraction is on the right side, right? Sorry about that, it's screen. My fraction's on the right side, so I'm actually going to work on the right side this time. All right? So if I'm working on the right side, which side should my equal signs be going down on? The left. So just kind of understand where you are and what side your equal sign should be doing. Okay. Well, let's see. Well, I have most of the stuff in sine and cosine already. I just had that secant to mess with, right? So I'm just going to go ahead and change everything to sine and cosine just to, get everything the way it should. So let's see, 1 over cosine x divided by sine x, right? Minus 2 sine x over cosine x. Notice my equal sign is on the left, right? Okay, let's go ahead and fix that first fraction. Let's flip the bottom. Remember that's sine over 1 technically. Flip the bottom and multiply. So that's going to give me 1 over sine x cosine x. Okay, minus 2 sine x over cosine x. All right. All right, now this just takes practice to kind of see this next step, okay? My goal is to get cotangent x plus tangent x, right? And if you notice right here, that's technically saying I have 2 tangent x's, correct? Okay, but how many of them do I actually want? 1. So 2 sine x cosine x is the same thing as actually saying 1 over sine x cosine x minus sine x cosine x minus sine x cosine x. Right? I mean, because there's just 2 of them. Okay? Well, I can take one of those, so I'm going to take this one, and just change it to tangent, because that's part of my goal. And then I'm just going to leave that one kind of alone. Okay? So this is going to give me 1 over sine x cosine x minus sine x over cosine x minus tangent x. Okay? So that's part of my goal. Now I'm going to leave that alone, so I'm just looking at the first 2 fractions now. Okay. Let's see. Well, let's put them together. Okay, let's see what happens if we put them together. You got to find common denominators, right? So that's going to give me 1 minus, let's see, this one's missing a sign, so this would be sine squared x over sine x cosine x, right? And then minus tangent. Remember, we're just going to kind of leave that alone, just kind of bringing it down. Okay? Well, the top of this is actually, well, that's an identity, right? That's just cosine squared x. Cosine x minus tangent x. There we go. Okay, and let's see. Well, cosine can cancel, right? So one of these cosines can cancel. And that leaves me with cosine x over sine x minus tangent x. What is cosine over sine? Cotangent. So that's cotangent x minus tangent x. Is that what we were looking for? Yes, that was what we were looking for. So we are good. Figure these out. Tangent x like that, and check. There we go. All right, your homework for today is numbers 13 through 18 on your homework page. Okay? We will be going over those tomorrow. make sure that you have them done. Make sure you have practiced these, because whenever I'm going over them, if you haven't practiced them, it's going to be just like today. I make them look easy because I have done these before. Okay, I've had lots of practice. All right? Make sure that you are actually practicing. Make sure that you are doing these. Okay? All right, so your numbers are, let's say, 13 through 18 tonight. All right? I hope to see you tomorrow.